We're going to talk about transversals today, and it's easier than yesterday. Okay, REQ. How can you prove and use theorems about angles formed by transversals that intersect parallel lines? We're going to prove and use theorems about the angles formed by parallel lines and a transversal. Our key term today is, you got it, transversal. Transversal is merely a line that intersects at least two other lines. A line that intersects at least two other lines. Okay? So when I say transversal, though, I will let you know. Most of the time when I say transversal, I'm talking about this transversal that's intersecting parallel lines. Okay? Parallel lines, non-parallel lines. Most of what we do today is going to be talking about parallel lines. Alright, what we're going to talk about is the angle relationships amongst the angles in parallel lines cut by a transversal. Very specific. Okay? Y'all know this? Said it? If you didn't know this before, now you know it. Complementary angles have a sum of how many? Said it. Complementary. What? No, that's supplementary. Complementary has a sum of how many? Supplementary has a sum of how many?
180.
Alright. Let's get to some more substantive material. Vertical angles. Vertical angles are two angles that are opposite angles. Vertical angles are congruent. In your notes, this is how I want you to organize them. You'll have a column that says congruent, underneath congruent, right? Vertical. You're going to have another column that says supplementary. Together, that's supplementary. Okay? Vertical angles. Go like this with your hand. This. Put your face in here. Okay? I've never done this before, so I don't know why. I just want to see what you guys look like. Okay? Right, if your face is right here, then the vertical angles will be right down here. Alright? Vertical angles. Right? Vertical angles are opposite of each other. Alright? 1 and 4 are vertical angles. 2 and 3 are vertical angles. 6 and 7, 5 and 8, vertical angles. Opposite of each other, right? Okay? Hopefully y'all know that one. Alright? Next I have what's called a linear pair. Very simple definition. Supplementary angles that form a line. Gee, I wonder how we got the word linear pair, right? They form a line. Okay? They are supplementary. Supplementary. Linear pair. Coincidentally, what's supplementary mean? I don't believe it.
It's the sum.
I'm just going to wait. You're going to get the answer, but I'm going to wait till everybody else stops writing and looks up. Because y'all are fine to keep writing. It's okay. Not telling you you can't. Just going to do my thing. I did ask you to write some things down. Not your problem. Hi. Estebanco. What's supplementary?
Sum of two angles that equals 98 degrees.
Any two angles that have a sum of 180, correct? Supplementary. With linear pairs, add up to be 180 degrees. So, like 180. Would that work? Because 100 plus 80 is 180. What about like 90 and 90?
No.
90 plus 9 is 180. Yeah, that's cool. Okay. What about 179 and 1?
Yes.
What about any combination between 1 and 179 that has a sum of 180?
Yes.
You got it, dude. So,
I have a question. Why when you said complementary, it just has to be congruent to equal 90, right? Well, 180 isn't the same, right?
Say that again?
Like, when you said 90 plus 90 equals 180, I thought they were supposed to be different instead of, I mean,
They don't have to, they can be.
There's two special types. When we talk about complementary and supplementary, you got two special angle measurements that are congruent and complementary, 45 and 45. They're congruent, but they're complementary. 45 plus 45 is 90.
so,
When I talk about supplementary, listen to how I say this. There's one special angle relationship that is congruent and supplementary. 90 and 90. They're congruent to each other. They're also supplementary at the same time.
so complementary, can it be also not the same thing? Or-
Most of the time it's not. You understand what I'm saying? I might, if we keep getting these questions, which it's okay to ask them, one day in class, we might just write down every single complementary relationship, which would entail you writing 1 through 89, and then 89 through 1. And we can do the same thing with supplementary if I feel like it, which is good. Congruent. What does congruent mean again? Equal. Very good. Okay, congruent. All right. So here's the best way to think about supplementary angles. All right. All right. Here we go. Preston. Preston. Pick an angle for me. 1 through 8. 4. All right, Preston, pick 4. There's nothing wrong with 4. Preston, here's how I can think about linear pairs. Okay? Which angles touch angle 4? Those are the linear pairs. Okay? They're not opposite, they touch. When angles touch, we call that adjacent angles, right next to them. Okay? You with me? Y'all following me maybe? So if I think about angle 4 plus angle 2 has to be 180. Okay? Coincidentally, angle 4 plus angle 3 also has to be 180. Everybody with me on that? There's something you need to know about this. Your linear pair is like your supreme, it's your defining angle relationship. In other words, we're going to classify these other ways, but if something forms a linear pair, the linear pair is how we recognize it, okay? Right? And you'll see what I mean by that later in the lesson. Just put that in your minds right now. Because next up, we got what's called corresponding angles, okay? Corresponding angles. If you want to write the definition, you can. If not, you can just watch. Corresponding angles correspond to each other, thank you, okay? The important part that I remember is that they are what? What column am I going to go in? Right here, congruency. Oh, let's start with a C, not an O, okay? Corresponding. Corresponding angles are congruent. That's great, Mr. Halls. What's corresponding mean? Glad you asked. Okay? Alright, here's what corresponding means. Corresponding means that two angles are located in the same spot on two different sets of lines. Now that doesn't make much sense. Okay? It does for some of us, right? Here's the easier way to remember it. Who's ever used a computer? All of you, because you have to take a test. Okay? How many of you know what, like, cut and paste mean? Perfect. So who doesn't know what cut and paste means? Good. Okay? Check it out, guys. See 1, 2, 5, and 6? If I cut those angles out and moved them over here and pasted them here, okay? The corresponding angles are the angles that would be on top of each other. Alright? That's one way I can think about it. here's another way I think about it. If I took a picture of this set of 4 angles, 1, 2, 5, and 6, okay? I took a picture of this set of angles, 3, 4, 7, and 8. The angles that are located in the same spot on both of those different pictures are corresponding angles. Okay? It's the second way. Maybe none of that's made sense so far. Let's try another way to think about this. How would you describe angle 5 in comparison, Kate, I'm talking to you. In comparison to 1, 2, 5, and 6, how would you describe the location of angle 5?
Bottom left.
Bottom left. Did y'all hear that? Bottom left. Go to these other set of angles, 3, 4, 7, and 8. Which one's located on the bottom left?
7.
That's the corresponding angle. Scarborough, how would you describe angle 6?
Bottom right.
Which one over here is bottom right? That's the corresponding angle to 6. So on and so forth. Okay? You got me? 1 and 3, 2 and 4. Those are corresponding angles. Okay? So far we've got vertical angles. What are vertical angles up here? Give me an example.
5 and 2, 7 and 4.
5 and 2, 7 and 4, 1 and 6, 3 and 8. Perfect. Give me one example of a linear pair. Seven and eight, linear pair, right? Okay. Jamie, give me one example of corresponding. 3 and what?
8.
Okay. What? Are you paying attention? Do I need to put you in front of Beth? Well, I will if you don't pay attention. Who's got corresponding? 5 and 7. Okay. So far, so good. Then it gets real, yo. Okay. Then it gets real. Here's what you need to remember on these. Okay? Alternate interior angles. They're congruent. 2 parallel lines cut by a transversal. Each pair of alternate interior angles are congruent. Hold on. Pause. Alternate interior angles. It's tough, right? How many of you have ever, painted before? Hey, what'd you paint?
Just one of it was a girl walking down the road.
I don't mean paint, I mean in your house paint.
Oh yeah.
What'd you paint?
Wall,
Where?
like on the sides
Where'd you paint? Your room. Where's your room? Inside or outside the house? Inside the house. Where'd you go? Lowe's or Home Depot? Home Depot. When you went to Home Depot to pick up paint to paint your room on the inside of the house, did you get interior or exterior paint? Because you put interior paint on the inside of a house, and you put exterior paint on the outside of a house, right? Watch this, guys. If I want to, which I will, and I can figure out my coloring scheme here. Where'd my pens go? There they are. I don't want that one. I want to highlight. There we go. Check it out. I'm going to paint the inside of these parallel lines. Here are my parallel lines, correct? I'm going to paint the inside of them. And just like I'm a great painter in real life, kind of. I have one of those guns. It's cool. All right. Those angles. Did I just paint the inside in between the parallel lines?
Yes.
What angles are highlighted? 1, 2, 3, and 4. Right. Those are your interior angles. The angles inside the parallel lines. All right. But these are not just interior angles. These are what kind of interior? Alternate interior. Okay? Alternate interior means they're on different sides of the transversal line. Alright? Different sides of the transversal inside the parallel lines. Okay? Now, some of you are like, man, But 1 and 3, 2 and 4. Those are going to be your answers, okay? How do I determine if something's on the same side or different? Got something for that. Anybody ever played Red Rover?
Yes.
I missed that game, right?
Yes.
Me too.
We should play it.
How did Red Rover go? Scarborough, how did Red Rover go? It's easy, Scarborough. Red Rover, send Tyler right over. And then what would happen?
Just trick and run.
Somebody would run and try and do what?
Break through the arms.
Break through their arms, right? Sometimes they literally broke their arms. I did that once. Okay? Which is why we don't get to play Red Rover anymore. Alright? So hey, check it out. If they're playing Red Rover right here, who's on the same side?
4 and 2 and 3.
Try it again. Here is the line. You're going right across
1
this
and
line.
2 and
Yeah.
4 and
1 and 2 are on the same side. 3 and 4 are on the same side, right? So 1 and 2 are going to holler and say, Red Rover, send 3 right over, right? So another way to think about this is 3 is on an alternate side than 1 and 2, or an opposite side, right? Yeah. I got to put all that together to get alternate interior angles. Opposite sides of the transversal inside the parallel lines. 1 and 3, 2 and 4. Okay? Alright? Make sure we add this to our list. Alternate interior angles. Right? With me so far? I'm going to go back to painting. Because the next one says consecutive interior angles. I'm going to paint it up. Here are my inside. That's interior paint, right? I'm inside the parallel lines, correct? Okay? If I'm inside the parallel lines, I've got consecutive interior angles. Check this out. Consecutive is the same thing as saying same side, meaning they're on the same side of the transversal. Tyler, you're playing Red Rover. Here is your field dividing the teams. Okay? Who's on the same side?
1 and 2 and 3 and 4.
Those are your same side interior angles then. 1 and 2 are same side interior. 3 and 4 are same side interior. Okay? And what does it say that they are? Are they congruent?
Supplementary.
Ah, they're supplementary. Okay? Same side interior angles are supplementary. I got one last one we got to talk about. Actually, we've got 2, but it's okay. I'll talk about that in a second. I've got alternate exterior angles. Tucker, now all of a sudden, I go to Lowe's, and Meemaw said I got to paint not the inside of the house, but the what? Let's paint the outside. It's going to be outside the parallel lines, isn't it? That means I got a little bit more work to do. Well, that doesn't work. That's okay. So over here, paint the outside. That would be the inside, wouldn't it? I won't paint that. Come over here and paint the outside again, right? I got the outside painted, don't I? Okay? Scarborough, let's go back to you. Do I want to choose people on the same side or alternate sides? So if this is my transversal, I'll help you out here. This is, well, you can't see any of that. 5, 8, 6, and 7. Okay? 5, 6, 8, and 7. Which pair are going to be outside and alternate? 5 and 7, and what else? 6 and 8. And they are what? Yeah, so my last pair of congruent angles are called alternate exteriors. Easy way to remember this. If you see the word alternate, they're going to be congruent. Right? If you see alternate, it's going to be congruent. Okay? Everybody with me on that? Anybody have to get to that thing, though? Here, we're going to learn how to identify and classify 1 and 3. What would that be? A what?
Alternate.
No.
Oh, what
What is supreme?
Oh, they're near.
Linear pair. See what I'm saying? Linear pair is supreme. Linear pair. Okay? Linear pair. 3 and 6. Alternate interior. 4 and 5. Alternate interior. 6 and 7.
Vertical.
Alright, good. Okay? Then I'm going to ask you to write those down. Alright, check it out. Check it out. Now, this is the type of problem you're going to see. Sudden, I see the big old eyeballs already. Watch this. Watch how easy this can be. Okay? Megan? Oh, I'm sorry. Madison. Sure that never happens. Hey, this and this is vertical, right? Vertical is what? So those have to be the same, don't they? Right? What's below congruent? So if this and this is located top left, bottom right, what are these two going to be? Okay. That's not bad, right? Is it? Right? I got a couple different ways to think about this next one, but watch this. What's the missing thing here? These two would have to add up to be how many? 180 minus 70, how many? What's that?
100. Oh, wow.
So the other missing angle is going to be what?
100.
And coincidentally, the beauty of transversals, you give me one angle, I can give you everything else.
So, I have a question. Now, would
No, go ahead.
that be the answer to X?
Well, you tell me.
Or would
Is
it have
5x, is x, if we multiplied 5 times 110, no, what do I have to do with x?
you have to divide it?
I gotta set 5x equal to 110, divide both sides by 5, 20 bucks says I get 22, okay? X is 22, right? Okay? That's how I would solve that type of problem, alright? Okay? Still confused, right?
Kind of, but didn't we do this in like 8th grade?
I think you did.
Like I know we for sure we did like the mapping and the 180 minus whatever
Good.
we got, but I don't remember like all the other.
All the other stuff, we're gonna take it up a step. I'm gonna simplify it before we do that though, okay? If I did this one, hey guys, hey, you don't have to do this on every problem, but you can. 118, 118, 118, 118, right? 180 minus 118, you get the rest, don't you? You can ask me any question on any of those angles and I know the answer. Vertical angles are what? Corresponding angles are what? Linear pairs are what? That means that, understand, when I do that right there, if you tell me supplementary and I subtract away, here's why I'm doing that. Supplementary means that angle plus some missing angle equals 180, correct? If I solve for question mark here, I would do what? Subtract 118. Okay? It's 62, isn't it? What the other missing angles have to be 62. That's it, boys. That's pretty easy, right? Boys and girls. Look, y'all get me? And understand, here's the frustrating part. That's the big picture, okay? You see that the big picture's easy, right? Come on, guys. You're subtracting something from 180, or you're saying it's congruent. That's not hard. What's going to make it hard is identifying which one of these 7 it is, okay? That's what's going to make it hard. Let me see if I can't help you out with something like this. Write this down. Write it down, okay? Write this down. I've got parallel lines cut by a transversal. You know what? I got 3 parallel lines cut by a transversal. You ready? that angle is X degrees, how much is this angle? If those two are X, what about these two? If those two are X, what about these two? Now let's check out here. Let's see. Let's make sure. If all those are X's, let's see. Are those vertical?
Yes.
Are those corresponding?
Yes.
Are those alternate interior?
Yes.
Are those alternate exterior?
Yes.
Got one more piece of the puzzle. Hold on one second, guys. Hold on one second. Let me finish the puzzle, then because I want to make sure you get it, okay? If this is X, naturally this is going to be what? Now we need our rules. Real simple rules. X is always equal or congruent to X. Y is always equal, congruent to Y. X plus Y is always 180 degrees. Is that XY a linear pair?
Yes.
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 Is that XY same side interior?
Yes.
Is that XY same side exterior?
Yes.
That's what I said.
That's the way.